Now we have this GATE series maths lecture, that is number 3. Now after determinant, we are going to switch over to matrix. So now matrix and determinant, we have change in the representation of this. So representation of 4 elements, that is in this bracket or in this bracket, that is called as matrix. For determinant, we are going to use only vertical lines. That is the major difference of the representation of determinant and matrix. So you can see, so this we are going to say as matrix, and size, other things we have same. So we are going to mention here, that is 2 by 2. First will gives you number of rows and second will gives you number of columns. So this is your matrix. So you can show it in this bracket also, then only it will be considered as matrix. Now types of matrix. So now we will go one by one. So we have row matrix. So matrix having only one row, and then we have in this number of columns. Any number you can have, that we are going to say as row matrix. Means if you have to show it, then we are going to mention it as 1 by n. So 1, 5, 7. So likewise any number of columns. You can see this. So this we have, that is 1 by 3, 1 row and 3 columns. Then column matrix, a matrix having only one column is called column matrix. So here we have number of rows. So this if we will see, so we have this will be 3 by 1. And so you can have this. So we can mention it as 7, 9, 8. So likewise, so this will be n by 1. Now column is always 1. That we are going to say as column matrix. Then 0 or null matrix, we have all elements of this are 0. So whatever matrix you have, so if you have 9 3 by 3, then also your all elements we are going to say these all elements are 0, and that we are going to say as 0 or null matrix. Then we have fourth square matrix. When rows and columns we have equal, then we are going to say as square matrix. So it may be 2 by 2, so it may be 3 by 3. So this is 3 by 3. Square means number of rows that is equal to number of columns, and that we are going to say as square matrix. Then we have diagonal matrix. When non-diagonal elements are 0, so you can see over here. So we have this as non-diagonal elements as 0, called diagonal matrix. Diagonal may or may not be 0. May or may not be 0, but non-diagonal elements should be 0. Then we are going to say as diagonal matrix. So you can see, say your null matrix, we can say as a diagonal matrix, provided it is a square matrix. Then we can have this. So we are like this. Now you can see non-diagonal elements. So we have diagonal along this. So we have these two are non-diagonal elements. So we have both are 0. Now diagonal, this one is also 0, then also it's okay. But non-diagonal element should be 0. You can have in this way also. 5, 3, but this non-diagonal should be 0. So that matrix we are going to say as diagonal matrix. Now scalar matrix, a diagonal matrix. So diagonal matrix means non-diagonal are 0. A diagonal matrix having diagonal elements same. So diagonal elements we have this and this. So these are same. Means if I will say in this, then we have this 5 and 3. If these values of these are same, then we are going to say it as a scalar matrix. So you can see this as 5, 5. Or it may have, if you have 3 by 3 matrix, then you have 1. Sorry, you have 2, 2, 2. And then all other non-diagonal, we are going to be equal to 0. So this is my scalar matrix where we have non-diagonal are equal. Sorry, non-diagonal are 0 and diagonal elements are equal. Then we have unit or identity matrix. So we have scalar matrix where we have diagonal elements are same and non-diagonals we have 0. But here diagonal elements are 1, that we are going to say as unit or identity matrix. So we can have like this also 1, 1, 1, then 0, 0, 0. It may be of any size. So this will be 3 by 3. This is 2 by 2. That we are going to say unit or identity matrix. Then upper triangular 0. Now a square matrix in which all elements, see, we have here upper, but which are 0? The elements which are below the diagonal are 0. Then we are going to say it as a upper triangular matrix. So below the diagonal are 0. So we have this as diagonal. Then we are going to be values below it 0. This if I will consider any other 3, 5, 6, 2, 9, 1. So this I will mention below diagonal and these all values should be 0. Then we are going to say upper triangular matrix. Then lower triangular matrix, when these are above the diagonals are 0, means we can have in this fashion. So if we will consider any other 4, 3, 2, 1, 6, 9, and then we have these values are 0. So we can have this diagonal and above this diagonal we have values as 0. So we are going to say it as lower triangular matrix. So triangular matrix means we have above the diagonal elements are 0 or below the diagonal elements are 0. Then we have 10 symmetric matrix. When we have Aij equal to Aj, what does it mean? So we have A1, 2, and that should be equal to A2, 1. Means if you will interchange your number of columns and rows, and then if elements are same, then we are going to say it as a symmetric matrix, provided it should be a square matrix. Then we can see this. So we can have this 4, 4 equal. If I will write 3 by 3, then we have 1, 2. So this is A 1, 2. Then we have here A 2, 1, which will be 2. Then we have this value as 5. We have diagonal. This is 7. Now this is A1, 3. Then we have A3, 1 over there. It should be same. Then here we have 3. So this we have that is A2, 3. Then A3, 2. We should have same value. And then this will be 4. So these values where we have Aij element value of Aij, that is equal to Aj, and that we are going to say it as a symmetric matrix. So now then we have a skew symmetric matrix. What is change? You can see Aij, that should be equal to minus Aji. Means if I will write this above matrix, which we have that is symmetric. So 2, 5, 3, 7, 3, 4. And then in this case, we have these values minus. Then if this is 7, this you can say as minus 7, 3, minus 3. Any of the value we have Aij, that is equal to minus Aji, and that we are going to say as skew symmetric matrix. Then we have next singular matrix. Now this is most important. Singular matrix means a square matrix is said to be singular if its determinant is 0. If determinant is 0, matrix is singular. Otherwise, that is known as non-singular matrix. So you can see over here. So we have this matrix that is 4 into 9 minus 6 into 6. So 4 into 9 minus 6 into 6. So we have 36 minus 36, 0. So this matrix we have singular matrix. Singular matrix. Then we can have next 13 transpose of a matrix. So the matrix obtained by changing rows into columns and columns into rows, then we are going to say it as a transpose. You can see we have this 3, 4 and 7, 5. So we have likewise, if we will consider a 3 by 3 matrix, so we have 1, 5, 7, 9, 6, 3, 2, 4, 8. So this is matrix, and if we will write transpose, then rows into columns and columns into rows. So first column will be 1, 9, 2. Second we have 5, 6, 4, and third we have 7, 3, 8. So this is known as transpose of this matrix. So we have these as the different types of matrix, or we can say properties of matrix. And so we will have this for matrix today. And now we will stop here only. So thank you.